Have you ever just stopped and really thought about what it means to be alive? I mean, what really separates a living thing from everything else? It sounds so simple, right? But the answer is actually this incredible journey into the very definition of life. So today, let's dive in and explore the surprisingly elegant rules that run this whole living world.
Let's just boil it down to this one simple question. What's the real fundamental difference between a rock and a rose? One is, just sitting there. The other is this vibrant, complex, living thing. But where exactly do scientists draw that line? Well, let's go find out.
So, here's our game plan for today. We're going to start with the ultimate litmus test, then uncover life's true hallmarks. After that, we'll get a handle on a world of variety, check out the great filing system that biologists use, and finally, figure out exactly where we fit in with our place on the map.
All right, first up, let's put our common sense to the test. Because when you think alive, a few things probably pop right into your head. But what we're about to see is that science needs rules that are way more strict, way more consistent than just a gut feeling.
Yeah, most of us would probably point to stuff like growth or reproduction. And hey, those are absolutely characteristics of living things. But, and this is a huge but, they aren't defining features. See, for a rule to be truly defining, it has to apply to every single living thing with zero exceptions, and to no non-living things. So let's see why our common sense answers don't quite make the cut.
Okay, let's tackle growth. Scientifically, this just means getting bigger, increasing in mass or increasing in number, like when one little bacterium splits into two. Seems like a total slam dunk for a rule of life, doesn't it?
Well, here's the catch. Non-living things can grow. A mountain gets taller as tectonic plates push it up, a sand dune gets bigger as the wind piles on more sand, and because there's an exception, a non-living thing that grows, growth fails the test. It's not a defining feature of life.
All right, so what about reproduction? Making more of your own kind. This feels like the most obvious sign of life there is. I mean, come on, this one has to be it, right? This has to be a defining feature.
And yet, we find exceptions again. But this time, the exceptions are actually living things. Mules, for instance, the offspring of a horse and a donkey. They're definitely alive, but they can't reproduce. Most of the bees in a hive are sterile workers. And of course, many human couples are alive and well, but are infertile. So, since not every single living thing can reproduce, it can't be a defining feature either.
So, if our gut instincts about growth and reproduction are out, then what's in? Well, this brings us to the real deal. The true scientific hallmarks of life. Biologists have this checklist, a kind of non-negotiable list of 3 features that every single living thing has, from the tiniest microbe to the biggest whale. No exceptions.
This chart really lays it all out. You see, growth and reproduction? Yep, they're characteristics, but they're not defining because they have exceptions. The real non-negotiables, the true hallmarks, are metabolism, cellular organization, and consciousness. These are the 3 that pass the test with flying colors.
So let's just quickly break these down. First, metabolism. This is basically the sum of all the chemical reactions happening inside an organism to keep the lights on, so to speak. Then there's cellular organization. This one's simple. If it's alive, it's made of at least one cell. That's the basic building block. And finally, consciousness. Now, this doesn't mean thinking deep thoughts. It's the ability to sense what's going on in your environment and respond to it. A plant bending toward the sun? That's consciousness in action.
Okay, so we figured out what life is, but, that just opens up a whole new can of worms, because there's a mind-boggling amount of it out there. How in the world do we even begin to make sense of all the different shapes and sizes that life comes in?
Just think about this number, 1.8 million. That's how many different species scientists have named and described so far. And we're finding new ones all the time. Trying to study all of that without some kind of system would be like trying to find one specific book in a library with nearly 2 million books just thrown in a giant pile. It would be absolute chaos.
And that is where taxonomy swoops in to save the day. It is biology's beautiful, elegant solution to all that chaos. You can think of it like a universal Dewey Decimal System, but for every single living thing on this planet. It's how we create order out of all that incredible diversity.
And the process itself is just wonderfully logical. When a scientist thinks they've found something new, first, they characterize it. They write down everything about it. Then they identify it by comparing it to stuff we already know. Based on that comparison, they classify it. They put it in the right groups. And finally, the last step, nomenclature. They give it a unique official scientific name.
And that naming game has a simple, universal set of rules, thanks to a botanist named Carolus Linnaeus. Every single species gets a two-part name. The first part is its genus, and that's always capitalized. The second part is the species, which is always lowercase. The whole thing is in Latin, and you always write it in italics. Like us, for example, we're Homo sapiens.
Now here's where it gets really cool. This classification thing isn't just one label. It's a whole hierarchy, a set of nested levels that go from super broad to incredibly specific. It's like a cosmic address for every living thing, pinpointing its exact spot in the grand scheme of life. To really see how it works, let's trace our own address.
We'll start at the very top, the biggest, most inclusive level, the kingdom. We, of course, are in the kingdom Animalia. This is a huge group, right? It's got everything from insects and sponges to us and blue whales.
Okay, let's take one step down to phylum. Within all those animals, we belong to the phylum Chordata. What does that mean? It means we have a spinal cord, and that one feature immediately separates us from things like jellyfish or insects. Getting more specific, we land in the class Mammalia. We share this group with every other creature that has hair or fur and feeds its young with milk. So that's everything from your dog to a dolphin to a bat. Now within the mammals, we find our order. We are primates. This group is known for things like having large brains and grasping hands. This is where we hang out with monkeys, apes, and lemurs.
Narrowing it down even more, our family is Hominidae. This is the great ape family. It's a pretty exclusive club, actually. It's just us, chimpanzees, gorillas, and orangutans.
And now we're getting really close. We arrive at our genus, Homo. This group is all about walking upright and having a really big brain. This includes us, modern humans, and our closest extinct relatives, like Neanderthals.
And finally, we land on our unique species name, sapiens. You put it all together, you get Homo sapiens. And that's us. That's our unique, complete address in this incredible library of life with millions of other species, all filed away in the exact same system. So cool.
I mean, this beautiful system connects everything that's alive, from a single-cell bacterium to a giant redwood tree, showing us exactly how we all fit together. So the question I'll leave you with is this. As we keep exploring our planet, what amazing undiscovered life is still out there, just waiting for us to find it and add it to our ever-growing library? Thanks for joining me today.